My specialty is to study the animals that are found around some very specific environments in the deep sea. One question I often get when I give presentations around the country is, what is a deep sea biologist doing in the middle of Pennsylvania? And the fact of the matter is the kind of work that I do does not require rubber boots and a plastic bucket. It requires access to big ships and expensive deep submergence facilities. I've worked all over the world, and my research starts with an airplane ride to a port. There we meet a big ship and the right facilities and take it from there. The Gulf of Mexico is a very unique place geologically. It is home to the largest oil and gas producing region in the continental United States, and it is also one of the most complex continental shelves in the world. So in the Gulf of Mexico, the northern Gulf of Mexico, we have oil and gas bearing shales with a salt sheet underneath them and a layer of sediment on top. And as these different geological forces interact, we get cracks in the oil-bearing shale and we get natural seepage coming out of the seafloor. So at thousands of different places in the Gulf of Mexico, oil and gas is naturally seeping very slowly from the seafloor. And in those environments, we have some very special communities of animals that have evolved to live there. The communities we study start at about 300 meters and go down to 3,000 meters. And with the Deepwater Horizon disaster at 1,400 meters in the Gulf of Mexico, we had an oil spill where the oil was being released at the same depth as many of the communities that we study. It was contained, collected, some evaporated, some was burnt off, and people are wondering where the rest went. Well, there's growing evidence that a lot of that oil has ended up in the deep sea on the sea floor. Our work on the communities of megafauna that live in these environments sets the stage to see if, in fact, this oil has impacted any of those communities. Part of the work that we've been doing in the Gulf of Mexico is to characterize and document the communities that are on the seafloor. So one specific aspect of that has been to very carefully, using high-resolution imagery, photomosaic portions of these communities. Now before we do that, we locate them very precisely on the seafloor and leave markers so we can return to them year after year after year. Well, this of course puts us in a perfect position to see if there's been any impact on these deep sea communities from deep water oil or deep water oil plus dispersant. Because we can return to locations on the seafloor that we know very well and we know exactly what's growing there and see how those animals are doing. We don't really know what we're going to find when we go back out to visit these communities. We don't know if they will be impacted by the Deepwater Horizon disaster, but they certainly may have. Even though some are adapted to oil, none of them are adapted to dispersant. And if there was a heavy exposure to dispersant in any of the communities, this could have some very serious toxic effects. If in fact the dispersed oil forms small globules, this could foul feeding appendages. It could foul respiratory appendages and have a very bad effect on these communities. Similarly, if in areas a deep water plume of oil and dispersant stayed cohesive, if it stayed intact, oxygen in that area could be depleted, and all of these animals require oxygen. So certainly we don't know that we'll see an impact, but there are a variety of scenarios where we could, and the only way to find out is to go down and take a look.